All right, welcome back. Today, we're taking a little trip to our next-door neighbor, Mars. You know, the red planet. It's dusty, it's mysterious, and it's hiding a huge puzzle that's had scientists scratching their heads for decades. So, let's get into it.
So, here's the big question, the mystery at the heart of it all. Where is Mars's magnetic field? I mean, Earth has this powerful magnetic shield that protects us from all sorts of nasty solar radiation. But Mars? It's just out there, almost completely exposed. So what happened? Where did its shield go?
Now, there are plenty of mainstream theories floating around, of course. But for this explainer, we're going to dive into a really different, pretty unconventional answer from an author named Miles Mathis. It's a fascinating take that might just change how you think about magnetism itself.
Okay, so according to the author, the problem is that mainstream physics kind of struggles to explain why a planet like Mars would have such a weak field. This leads to theories that to him just don't feel convincing, like the idea that Mars's magnetism was just, blasted away by asteroids. He thinks we need to look at this from a totally different angle.
So what is that different angle? Well, the author's core idea is that magnetic fields can be neutralized. He suggests that if you get the conditions just right, two opposing magnetic forces can basically just cancel each other out, leaving a planet totally exposed. He calls this spin cancellation, and the idea is pretty wild. He argues that magnetism is actually created by the spin of photons. So think about it like two toy tops spinning in opposite directions. If photons with opposite spins run into each other, their magnetic effects can just disappear. They neutralize each other. This one idea is the key to his entire theory, so keep it in mind.
And to show how this works, he first looks at a couple of other places in our solar system. Take Venus. He argues that its upside-down rotation makes its magnetic field clash with the sun's, and boom, cancellation. Then you have our moon. It's so close to us that its field smacks right into Earth's head-on, and you get the same result. See the pattern? Two totally different reasons, but the exact same neutralizing effect.
Okay, but this is where the plot thickens, because when we turn our gaze back to Mars, we realize that neither of those explanations really fits. Mars is a whole different ballgame. It's a much more complex, much more subtle puzzle.
I mean, let's be real clear about this. Mars isn't spinning upside down like Venus. It's not tucked away in the shadow of a giant neighbor like the Moon. In fact, its rotation speed is a lot like ours here on Earth. So, by all those measures, it should have a pretty decent magnetic field, right? Which leads to the million-dollar question. If something is canceling out its magnetism, what in the world could it be?
And this is where the author's theory really comes into its own. His answer is that Mars's weak magnetism isn't about Mars itself, but about its location. He says Mars is stuck in this incredible cosmic balancing act, a magnetic tug-of-war between the sun on one side and the giant outer planets on the other.
So here's the theory. You've got photons with one kind of spin coming from the sun, pushing outwards. But at the same time, you've got photons with the opposite spin coming from the four gas giants, Jupiter, Saturn, Uranus, and Neptune, pushing inwards. And Mars just happens to be orbiting in the exact sweet spot where these two gigantic opposing forces meet and almost perfectly neutralize each other.
Now, the source material gets into some really heavy math here, but don't worry, we're just going to walk through the logic of it. It's actually pretty straightforward. First, the author calculates the sun's magnetic influence on Mars. Simple enough. Then, he calculates the combined magnetic pull from all four of those giant outer planets. The whole point is to show that right where Mars is, these two forces are so evenly matched, they basically just cancel out.
And check this out. This is what that logic looks like. The sun's influence, right? He pegs it at a relative strength of about 5.6 units. But then, the combined push from the outer planets is almost just as strong, coming in at 4.75 units. So what's left over? A tiny net field of just 0.85. It is an almost perfect cancellation, a cosmic stalemate.
So what's the bottom line? After running all the numbers and comparing Mars's unique situation to Earth's, where these forces are way more out of balance, the author comes to a pretty stunning conclusion. Mars's magnetic field should be about 4,000 times weaker than our own. And here's the kicker. That number is incredibly close to what our current scientific instruments actually measure. Pretty wild, right?
But hold on, the theory doesn't stop there. It also gives us a really cool explanation for one last piece of this puzzle, and that is the ancient supermagnetic rocks that we found scattered all over the surface of Mars. You see, scientists found that a lot of old Martian rocks have this strong leftover magnetism, It's like a memory of a time when Mars must have had a really powerful magnetic field. Now, at first, that sounds like it totally contradicts a theory based on a cosmic balancing act, right? But the author says, no, this is actually the clue to a much, much bigger story.
His conclusion is that these magnetic rocks are basically fossils. They're telling us a story that says millions and millions of years ago, our solar system looked very different. Either Mars itself was in a completely different orbit, or the giant outer planets were in different spots. Either way, that delicate cosmic balancing act just wasn't happening back then, which meant Mars was free to have a strong magnetic field of its own.
As the author himself puts it, these rocks are like tablets with numbers on them. He believes that if we study their magnetism, we could actually start to work backward, almost like cosmic detectives, and piece together the entire history of how our solar system has changed over time. And that leaves us with one last, really mind-bending thought. What if the entire history of our solar system is actually written in the magnetism of rocks? It suggests that a planet's magnetic field isn't just a shield. It could be a cosmic Rosetta Stone, just waiting for us to decipher the secrets of our solar system's wild and chaotic past. Makes you wonder, what other histories are out there, just waiting to be read in the stones of other worlds?